Yeah, good morning, everybody. So, today's class will be about modular design and life cycle design approach. So, we will discuss the concept of what is modular approach in design engineering and how does it help the designers. Also, how the life cycle design approach influences design decisions. So I will tell in brief modular design. So what is modular design? Modular design consists of modules. Say for example, you have a complex problem. So that complex problem, how do you solve in the modular design approach? You will divide into different modules or components or elements. A complex problem or a large problem you break into sub problems. So and then you try to solve the sub problem. If the sub problem are the so-called modules are again difficult to solve as such, you again break that module or sub problem into further divisions, further modules or further sub problems until you can handle the granularity, until you can handle or solve the the problem at hand. Then later what will you do? You will combine the solutions to different modules and you will thus reach the solution for the larger problem or the initial problem where we started. So that is modular design. Say for example, important one important example that we are all familiar with is the laptop or computer itself. See, look at the laptop or computer. What are the components it consists of? It has keyboard, mouse. Probably you have. Then you have display. Then you have sound card. Then you have hard disk, memory, processor. Everything is a separate functional element. So what is advantage? Advantage is if your keyboard becomes faulty, you can immediately replace the keyboard. Or if you want to have another mouse, you can connect it. It doesn't affect the other components of the computer or laptop. Or if you have a memory requirement, you can increase the memory requirement. Your motherboard, whatever motherboard, if you want, suppose you want to assemble a computer, you can have your own motherboard. You can have the size of your memory. So each one is separate and each one is in we cannot say independent, they are dependent, but they are in a modular fashion. So that is the modular. So this computer is designed in a modular approach, so it consists of different modules. So that is the basic idea of modular design. Or even in the case of a software also, if you look at, so the computer basically consists of hardware and software. We in this example we looked at the hardware side. So if you look at a software project, a large project, you may do in higher semesters your mini project or project. So your major project, say for example a website or a software which will initially it will have a lot of requirements. So how do you solve that? How do you think of the design? How do you think of the implementation? You will definitely break that problem into different modules. Software, different modules. A campus management system. For campus management system may have student attendance, student internal marks and details, or your fee payment details, your hostel details. No, they are all modules. Hostel is one module where you deal with hostel accommodation, your room allotment, your furniture and other details present in your room, which room and who are all your roommates. Those details will be there in the room hostel module. Your payment module or fees module, the fees you paid, anything due, that will be shown. And your academic module or in series exam module will consist of your internal marks, your university marks, how many subjects you scored more than 80. All the details related to your academics will be there in the academic module. So that is the modular approach of designing a software. So this campus management system itself is a large module, itself is a large function. So we cannot think of that while solving the while designing this, while implementing this, while developing this campus management system. It is the easier way to look at solving that problem. So how do you do? We'll divide that into, we'll break the campus management system into different modules: attendance, series exam, internal marks, hostel fees, any other details. So whatever details required, that they are depending upon how the designers think, how the customers, what are the requirements of the customers. So depending upon that, you will have a modular design. So that is the idea of modular design, where you think of different modules. Then second concept today we will be discussing on is life cycle design approach. So what do you mean by life cycle design approach? Life cycle design approach involves, or it considers the life cycle, entire life cycle of a product. Say for example, you are designing a new laptop. Okay, so what are the life cycle stages? So right, it consists of different modules, different components. So right from the collection of raw materials, so everything is composed. So how a keyboard is manufactured, how a mouse is manufactured, how my processor is manufactured, how memory is manufactured. So semiconductor, or what are the materials used required. So raw materials, then you have different components, then that will be used. Then finally, sometimes if the device or component becomes faulty, you will have to replace that. Sometimes you will have to throw it away. Sometimes you can recycle it, isn't it? Or you can go for a new product or new part. So entire phases of the entire phases, or entire or all the stages in the life cycle. Life cycle of a mouse means what? Raw materials, then it is converted into a mouse, then it is used by somebody, then finally what happens to that? Can we recycle that, or can we, or it will be an e-waste which needs to be taken care of. So that is the idea. So finally, what happens to that product, what happens to that material? So these are the various stages. Now what is the focus here? Here the focus is it should be environment friendly. Environment friendly means it should not create any harm effect for human beings, our environment, or people or society. Or in other way we can say this emission of various poisonous gases. Sometimes the lead, mercury, these chemicals, these they are considered as harmful, or this liquid crystals. So when you think of a display, which one is better? Whether the display CRT based display or LCD based display, and what is the amount of this harmful material used in the design? Say for example, lead used in CRT is 25 times more than the lead used in LCD display. So that way, so in that case, which is more environment friendly? Environment friendly design is the design which uses less amount of toxic material, less amount of harmful material. That way we are polluting less. We are contaminating our soil, air, water less. So that is the approach. So we consider, so right from the raw material till the product, till the component is produced, when it is used, and finally it is recycled or whatever it is done with that product. So that is a life cycle design approach. So here the design, it's a design approach. Life cycle design approach and modular design, they are approaches taken adopted by the designers. So in the life cycle design approach, in the design phase itself, design phase means what? We are going to manufacture, we have not manufactured it. So we will take a decision which material we will use, how it is going to be recycled, what happens to that, will it emit any toxic gas, toxic material, will it be harmful to, will it contain any harmful element inside? So those aspects are taken care of in the life cycle design approach. So the designers will design a product which is environment friendly, which is sustainable, which does not harm our environment, our air, water, or soil, isn't it? So that is the idea of life cycle design. So that is the concept of modular design and life cycle design approach. Is that clear to all of you? Difference between, or how the concept is meaningful in the case of a design. Is it clear? Please give your feedback in the chat. Aditya, yes. Siddharth, yes. Amal Raj, yes. Okay. So we'll understand it more when we go through the various slides. Okay. So modular design approach. Um, Modular design is an approach in which engineering projects, even complex ones, are created using standard modules. Starts from the top or the highest level module and moves towards the lowest level modules. In this technique, the lowest level module or main module for developing the software system is identified. A computer is one of the best examples of modular design, as I told, computer or laptop. Typical modules inside a computer are power supply units. We have power supply units, we have processors, we have main board, motherboard, we have graphics card, we have hard drives, we have optical drives, we have mouse, keyboard, so many components are there. All of these parts should be easily interchangeable as long as the user parts that support the same standard interface. Because when a mouse becomes faulty, you can replace the mouse with the mouse from some other company, because both the mouses or all the mouses will be following a particular standard. So any mouse or any keyboard which follows the typical standard, required standard, you can replace that product. So that is the idea of modular design, or that's the advantage. So basic idea is to organize a complex system as a set of distinct components that can be developed independently. That can be developed in it, because the development of a mouse and the development of a keyboard, that can go in parallel, because there can be two people, two sections, two divisions which are working on the development of, one is working on the development of a mouse, one is working on the development of a keyboard, another one is working on the development of a processor, because all these things they can do in parallel and they can be independent and then assembled together. Then finally they are assembled together to form the computer. Modules, the meaning separate elements. A product is designed for assembly in module-wise fashion. Modular product are the artifacts composed of various modules. These modules function together to get the overall function of the product. Car, if you look at a car, there are electric parts, mechanical parts. It has engine, it has light, it has sensors. Everything is module. Computer, program also consisting of different modules. A simple program also we can write. Say for example, you want to accept two numbers, then find the sum of the two numbers, then print the sum. So this you can write as three modules. Even though this is pretty simple, this will be enough to understand the idea of module. What you can write a function to accept two numbers from the user. That is one function. So that is one module. Another function you can write which will find the sum of two numbers already received. That is second function, second module. Third function is just to display the sum on the display screen. So that is third function. So these three functions constitute the entire program to accept two numbers and then to find the sum of those two numbers and finally display the number on the screen. Then you have website. A website has interface, user interface, front end, back end, isn't it? Software also, campus management software or banking software or railway reservation software. Any type of software you think of, you find then that they are also consisting of modules. The main module is divided into several smaller and simpler sub-modules or segments. They are also called segments based on the task performed by each module. Then each sub-module is further subdivided. If you want to divide, or if you can handle that sub-module, then you stop dividing. You do with that, you implement or you deal with that module. Otherwise, if you think that it is again complex, or if you find that if I divide this sub-module into further modules, it will be easy for me to manage. It's all about management. It's all about flexibility of implementing. And finally, integrating together all the sub-modules to the larger product, and that final integration will form the final solution to the original problem. This process of dividing each module into several sub-modules continues until the lower level modules, which can be further subdivided, are not identified. You can then combine these modules in different ways depending upon the needs of the project. So this is a diagram of modular design. You have main module, then sub-module 1, sub-module 2, sub-module 3. So main module is at level 0 and sub-modules at next level, level 1. Then you have level 2. So here the division stops at level 2. So you have initial problem, say a software, that is main module, campus management software, or a computer. Main module, you have a computer. Then you have various components. Then you have various sub-components. Say for example, main module is divided into input-output unit. Then come processing unit, arithmetic logic unit, then memory unit. Input-output unit, probably again you subdivide keyboard input unit and output unit. Then input unit again you can divide. There are different inputs unit. Keyboard is one input unit. Mouse is another input unit. Then output unit you have display, you have printer, isn't it? So this is the diagram of a modular design. So here 3 levels of division are shown: level 0, level 1, and level 2. So benefits of modular project designs. First one is saving time and money. This is by far the biggest advantage to modularity. It allows for reuse of existing code and process. Why reuse of existing code and process? Because when you have a module which is already working now, the same module you can use anywhere. Because you have a keyboard which is working, or you have a mouse which is working, you can fix that mouse to any computer during the assembly of any computer, because that will work. Or if you have a software, if you have a software module, in the simplest example I told you that accepting 2 numbers, then finding the sum. If this accepting 2 numbers and finding the sum, those modules are working, then you can, wherever you want to accept 2 numbers, the same code you can copy and paste. Or whenever you want to find sum of 2 numbers, you can reuse that code. So that is the advantage of modularity. So when you reuse the code, it actually saves your time, because you don't need to reinvent the wheel again. You don't need to spend time to write the same code again. So thereby saving the money also, because the employers will be spending less time on this project, and thereby you can save money also. So minimizing the cost, direct project cost, and project design and delivery time also will be improved. So that is the first advantage of modular project design, saving time and money. Second one, reducing rework and leveraging organizational knowledge. So reducing rework, because the same thing which is done already, you don't need to do it again. So no need for recreating the wheel or reinventing the wheel, because the wheel is already there. Wheel has been invented, so you can just use the wheel. So by creating standard modules and reusing them across different projects, you can drastically reduce the amount of rework your engineers have to do. Future proofing. So the future proofing means you are considering the future also. So if you are running a company, you need to think of the future also. In future, what would be the scenario? Sometimes the situation will be different, or sometimes I will have to, in that case, if the situation or requirement changes, I will have to make some modification in my existing program or software, because I have a campus management software right now. In future, the requirement might change. In that case, since I have a module already running, already working, I can modify that module to meet the requirements of the users in the future. So that is why this future proofing will be another advantage if you think of modular design. How will your firm compete with low-cost competitors for future work? What will you do when the project demands are high, but the budget time for hiring additional engineers are not enough? Implementing a modular approach and starting to build your typical library now will help you be ready for whatever challenge tomorrow throws your way, because tomorrow whatever modification might come your way, you will be able to do that, because you have various modules, and what is required, you don't need to reinvent the wheel. You only need to customize, you only need to modify your existing modules to meet the future requirements, or to meet the change in the requirements of users in the future. Flexibility and customizing. Yes. Unless you design the same plan over and over, you'd undoubtedly run into many situations requiring customization. Standardized modules allow you to tackle this problem, because you have modules which can be customized according to different users. Say, for example, you have a campus management software, and that software you sold to one institution, say Vimal Jyoti. Then later on, some other college, say Amal Jyoti, Kanjirapalli, you want to sell this software. Then they may have slightly different requirements depending upon their internal working. Here we may conduct 4 series exam, there they may conduct 3 series exam or 5 series exam. So what you can do there at that time, since you have already a module which is working, which is dealing with the series exam, and it is taking care of 4 series exam which is working. Now you just modify that to that module to meet their requirement of 3 or 5 series exam. So customization is easy, so flexibility will be easy. So this is possible only because you have different modules, isn't it? Design of a single part easier, as the designer can concentrate on that part alone. Modules can be separately improved without affecting the entire product. I can improve the individual modules without affecting the other modules. I can improve the performance, I can make modification, improve the reliability and quality. Concurrent engineering. Concurrent engineering, also called simultaneous engineering. Multiple engineers work on different aspects of the design at the same time, because they can be done in parallel. As I told, different modules can be given to different groups in the same design team, and they will be working on different modules, and there is no problem. So concurrent, engineering, concurrent simultaneous engineering is possible. This saves time and money. So as no one has to wait for someone else to finish. With modular design, engineers can work on different modules independently and then bring together to create the final deliverable. Outsourcing. Similar to concurrent engineering, outsourcing work is much easier using a modular approach. You can simply assign your outsourced talent specific modules to work on rather than having to integrate them fully into your systems and processes. You can outsource something. Say your project has 5 modules. 5 modules, out of 5 modules, one module you think that you do not have enough expertise or you do not have enough resources to develop inside your organization. So what you can do, you can outsource that particular module alone, and the remaining 4 modules you can ask your employees to work on and design. So that way outsourcing is easier. Tracking and analyzing data. Standardized modules also allow you to better track and analyze your project data. For example, you can record how many times a particular module has been used, how often it has to be modified, and what is the performance and repair metrics look like. So you can take analysis of individual module. You can design your software in such a way that it gives the statistics of each and every unit. Right now you have processor. You can have processor statistics in your computer. You can have memory statistics, how much memory is consumed, what are the processors running on, isn't it? All details are available. So this information will help you improve your internal process as well as raise the quality of the work you deliver to your clients. So is this clear? Modular design. Anaka, yes. What about others? Aditya, Ranjul, yes. So that is the idea of modular design. Okay. Next is life cycle design. So life cycle design, application of life cycle concept to the design phase of the product development process is known as life cycle design. LCD means life cycle design. Application of life cycle concept to the design phase. So what is the life cycle concept? All the phases of products life cycle, such as pre-production, production, distribution, use, maintenance, disposal, recovery. All these phases are considered. Pre-production means collection of raw material, selection of raw material, the choice for raw material that ultimately decides the product. Now, which raw material are we using? Is it harmful? Is it or environment friendly? Then finally, when you produce, what is the production process? What is the process through which you make you manufacture? In that process, is there any harmful effect on the environment? Then distribution, how do you ship your consignment from one location to another? Which mode of transport you use? Is it by road? Then is it by rail? Is it by sea? Is it by air? What is the mode of distribution? Then finally use. When you use, any issue or any issue or any toxic environment, toxic element, then maintenance. Is it easy to maintain? Or in that case, any issue? Then disposal. How do you dispose this? Or we call the e-waste management is an issue. So disposal, how do you take care of, how do you manage, how do you design the disposal? Then how do you recover, how do you recycle the product? Can you recycle it? So if you can recycle, then it is advantageous, because the wastage will be less, isn't it? So you should finally decide or design that this can be the element which you are thinking of should be recycled, isn't it? So these are the phases. These are the various stages through which a product goes through. A product goes through pre-production, production, distribution, use, maintenance, disposal, recovery. All these phases, all these stages, your product goes through. Your software product or hardware product goes through. Then in every phase, the effect on the environment is considered. So that is the life cycle design. So life cycle design is an environmentally sound design of products based on the whole life cycle, starting from exploitation, processing of raw material, pre-production, production, distribution, to use and returning materials back into the industrial cycle for recycling. Environment friendly product design. So it is ultimately an environment friendly product design. That is ultimate objective. A life cycle approach takes into account all the relevant impacts on the economy, the environment, and the society. So is it economical to go with that particular design? Is it environment friendly, or is it safe for the society or the people to use and deal with, interact with? So all these factors, economy is considered, environment is considered, and the society is considered. So this is a life cycle approach. While designing a particular product, we consider the impact of our product in all the stages, in all the life cycle stages, starting from pre-production till recovery till recycling. What is the impact? What is the effect on economy, environment, and the society? So such a design is called a life cycle design approach. The overall context of environmental and disposal problems during the whole life cycle of a product, from design to use to the use of recycled substance and waste disposal, to be considered. An environmentally desirable product design based on the careful treatment of resources and the prevention of waste and harmful substances assumes the highest priority in this case. Its life cycle approach enables product designers, service providers, government agents, and individuals to make choices for the longer term and with consideration of all environmental media, that is air, water, land. It is a product management system that helps enterprises to minimize the environmental and social burdens associated with their product or product portfolio during its entire life cycle. So there we use the life cycle analysis. So what is life cycle analysis? Life cycle analysis is the analysis or the study of the impact of this particular product when it is going through various stages on environment, society, and economy. So that is the analysis. So life cycle analysis helps you to understand the impact of this particular product, isn't it? So life cycle analysis enables you to estimate or calculate the impact. So that is how we calculate. We calculate lead is harmful for a human being, or mercury is harmful. So we should try how much or what is the quantity of lead and mercury or liquid crystal present in a particular hardware. So we will have to estimate it. Then we need to compare if which one is having less lead inside, which one is having more lead inside. As I told now, CRT, cathode ray tube display, and liquid crystal display. So which one is having more lead, more mercury inside? So that analysis is called a life cycle analysis. Then we will make the design choice. Analysis of environmental problems showed that the broad variety of materials used, the economic components, and the use of problematic materials, they were responsible for the negative environmental effects caused by complex products. So ultimately, it is focusing on the sustainability, sustainable engineering, sustainability product. So the ecological principles which we can follow throughout the design of any particular product, and if you want to make that design as life cycle design, you should be concentrating on saving the resources. You should not deplete natural resources. This is applicable to all branches of engineering, not only for computer science, computer hardware and software, any branch of science, all the branches of engineering prevailing or in use. So we should be concentrating on saving the resources, saving the natural resources. And we should use renewable and sufficiently available resources as far as possible. And we should increase the product durability. If we increase the product durability, then recycling or e-waste will be less, isn't it? Otherwise, if we purchase a product and it goes faulty within 2 months, 3 months, then that is a waste. Then it is an environmental hazard, environmental waste. It's an issue, environmental problem so in that case, what should be the focus of a designer? He should increase the product durability and design for product reuse. It should be reusable, it should be recycled. Design for material recycling, minimize harmful substances, as I told, lead, mercury, or any other harmful material, harmful toxic material. We should minimize the use as far as possible in our product. Produce in an environment friendly manner. All the processes in the manufacture, in the factory, all the processes that we follow should be environment friendly as far as possible. Minimize environmental impact during the product use. Use of environment friendly packaging. This packaging also, when you ship your consignment or all the material from all the products from one location to another location, from the manufacturing plant to the distributor side, the packaging, the type of material which you use for packaging, is it environment friendly? Or are you using plastic or some e-waste or some waste material which is very difficult to degrade or degenerate? then that will be pollution. That will be polluting our soil, water, isn't it? So packaging also taken care of. Dispose of non-recyclable materials in an environment friendly manner. How can you, are you planning to recycle these materials in an environment friendly manner? You have such any such approach, or is it possible to do in that way? Implementing environment friendly logistics, transport. Which method you use? Logistics means transport, as I told, which is less polluting. If you use road transport, rail transport, or ship transport or air transport, the rules are intended to be used for a systematic development of ecologically sound design products. These are the rules which should be used for systematic development of ecologically sound design products. So this is one diagram. Here, various stages of the product when it is going through. So product, how product design, then raw materials extraction. You have the design, then raw materials extraction and processing, then product manufacture. Third one. Then you have packaging and distribution. Then you have product use and consumption. Then finally end of life or disposal of that particular product, and it takes a new life. So in every case, what is the input? The arrow shown: labor, energy, material. Labor means man hour. People need to work. Then energy needs to be consumed. Then a lot of materials it might use. Then what is the output? Emissions to land, air, and water. In product design, the design process, emissions to land, air, and water. Raw material extraction processing, emissions to land, air, and water. Product manufacture, during that, emissions to land, air, and water, any pollutants. Emissions to land during packaging, during product use, then end of life, or when you recycle, when you dispose the e-waste, recycle, manufacture, then you are in fact considering the social impacts. So by calculating the emissions to land, air, and water, what you are actually calculating? Social impacts. So this is the various stages of life cycle of a particular product, and sometimes it can be reused. The end of a product, so it can be reused in some other way. So it can be recycled. It can be recycled into to manufacture another product. So that is also possible. So what are the possibilities? In all cases, what is the impact on environment? That is what we are considering. The selection of design alternatives must be guided by considering the various stages of product life cycle by giving importance to environment, society, and people. So we should consider emission of greenhouse gases, carbon dioxide, methane, carbon monoxide, less pollution to air, water, and soil, less toxic materials emission, consuming less energy. Altogether, if your process consumes less energy, then in fact you are conserving energy. You are preserving the natural resources. Then how it is transported, as I told now, through trucks, ship, or plane. Packaging, which material is used for packaging? Are the materials environment friendly? Are we recycling or just putting in the waste bin and then disposing them? Environment friendly approach of design is the ultimate focus, and thereby we are sustaining the natural resources, and we are preserving the resources for generations to come. We are preserving our land, water, air. No, we should not be selfish. No, the future generation also, next generation also should be able to use our resources. You use our natural resources. We should not think that we are the only owner of this earth and our universe, and we can do whatever we want with this air, water, or natural resources, or soil. We cannot contaminate. We should preserve them. As a responsible citizen or responsible human being, we should preserve the resources for future generation also to for them also to use. So that way, so when we design a particular product, when we run a manufacturing plant, when we run a company, all the methods, all the design approaches that we follow in our company, should be environment friendly, should be sustaining the resources, should be keeping the nature and its resources in a safe position. So that is the aim of having a of this design, environment friendly design, life cycle design. So that is called the life cycle design. So that is the idea of life cycle design. So I think this is clear. Life cycle design and modular design. So thank you.